With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? There is a deflection magnetometer which is placed with its arm along the east-west direction, and a short bar magnet is placed symmetrically along its axis at some distance with its north pole towards east. Okay, so we just represent it with a situation. Let's say this is our bar magnet. Okay, and let's say this is our this magnetometer. Okay, now this is placed. So this end, basically this we just draw our east-west, north-south direction. So this is our north-south direction, and let's say this is our east-west direction. We just mark this is our east, this is our west, this is our north, and this is our south. Okay, so in this way, so this is basically in this direction we are having our this deflection magnetometer. Okay, so it is placed in our this east-west direction, and there is a short bar magnet which is placed symmetrically along the axis. So this is the axis, and it is placed like this at some distance with north pole towards the east. So this is the north pole of the bar magnet, so it is placed towards the east, and this is the south pole. Okay, now the deflection, so due to placing of the magnet, so it would be shifting towards 60 degrees. So for example, theta would be equals to 0 degree, and at certain location, let's say at this location, our angle is 60 degree. So our this deflection magnetometer is tilting toward this axis about this hinge point. Now we need to find, if we double the distance of the this bar magnet, then the deflection will be. Now if we are doubling this distance, okay, if we are moving it further away from the bar magnet, what would be the deflection? Okay, we need to find this value. Now how can we do this? Now we know that so this would orient in the direction of the net magnetic field. Now, what would be the value of the magnetic field due to the bar magnet, okay, at a distance of d? So we know that it would be this would be its axial position, or we can say that it is its end-on position. So due to a bar magnet, if the magnetic moment is given as to be, let's say the magnetic moment is capital M, and 2L is the length of the bar magnet, and d is the distance between these two. So the magnetic field due to this bar magnet would be equals to mu naught divided by 4 pi, then 2m d divided by d square minus L square to the power 2. Okay, now for the case of, it is given that the bar magnet is a short bar magnet. It is a short bar magnet, so this length would be very small. So we can approximate this relation as to be mu naught by 4 pi, then it would be 2m, then in the denominator it would be d to the power 4, because this term would be 0, and from the numerator 1 power would be cancelled. So we can say that it would be 2m divided by d cube. Now from the this tangent law, what we can write? We can say that this would be basically, this b would be bh into tan of theta. So where bh is the horizontal component of the Earth's magnetic field. So from this relation, if you put this value, so this is the deflection, okay, along which it would orient. Theta is the deflection due to at which the magnetometer would be orienting itself. Now we can put the value. So this term mu naught by 4 pi, then 2, basically m, these terms are the constant. What is the just changing term? It is the d. So we just put this constant as to be k. So we can just write this as to be k over d cube. This would be equals to bh tan of theta. Now from this relation, what we can see, everything is constant. What would be changing? We are changing the distance. So we can say that our tan theta would be inversely proportional to 1 divided by d cube. Okay, so from this we can just see that as we increase the value of the d, now our tan theta would be decreased. So we can say that our tan theta 2 divided by tan theta 1, this would be in the inverse ratio of the distances. So it would be d1 divided by d2 to the power 3. Okay, now what would be the value of tan theta 2? Now tan theta 1 is given as to be 60 degree. We see from here it is given as to be 60. So tan 60 would be equals to root 3. Now what is d1? D1, let's assume that d1 is to be d. Now what is d2? We are doubling the distance, so it would be 2d to the power of 3. So this would become 1 divided by 8. So from here we get the value of theta 2 as tan inverse of root 3 divided by 8. So this is the value of the theta 2. So which option would be the correct option? So correct option would be our C option, tan inverse root 3 divided by 8. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level, Trusted by more than 5 crore students. Download Doubtnut app today.